Okay, very good morning to you all. Am I audible to you all, guys?
Yes, miss.
Okay, today I am taking this is my last lecture. So this is the last part of your module. But anyway, there is a part I didn't teach you. You need to refer that one regarding the environmental pollution. So I will give you what to refer, and definitely I will put one question from that. Okay, then the electrochemistry. I think sometimes you may have known this term because in O level also you learned uh, electrochemistry related things. Even you didn't have opportunity to learn about electrochemistry in A levels, but here electrochemical, it is the process. It is a chemical process which cause electrons to move. When we talk about before moving to the electrochemistry, so the things I think when you remind the electrochemistry, you may remember the electrochemical cells. When it is in the electrochemical cells, we are talking about electron transfer. In one end, oxidation will be taken place, at the another end reduction will be taken place. So that is how it is happening in electrochemical cells. So that is also one of the occasions in electrochemistry. So this movement of electrons is called electricity. And this is generated by movements of electrons from one element to another in a reaction known as oxidation and reduction. We will talk about this phenomenon later. Okay, before moving into the electrochemistry, there are some terms you need to remember. So, I think when we talk about the conductors, conductive materials. What are conductive materials? Conductive materials mean the materials which has ability to transport carry electricity. Those are the conductive materials. When it's come to the liquid electrolytes, the liquid solution of something conducting electricity, it is referred to as electrolytes. When we talk about the electrolytes and electrolytes, there are a few types. Some can be strong electrolytes like sodium chloride, HCl, H2SO4, that like that. And some electrolytes are very weak electrolytes. In water and acetic acid, like those compounds. I didn't mention those things here, but I gave you some example. So the examples for electrolytes are given here. The aqueous solutions of ionic compounds, that is aqueous sodium chloride, that means Lunu Vatura. Then aqueous copper sulfate. When you did some practicals in your O levels, I think you remember that blue color solution, it is a copper sulfate aqueous solution. There are some liquids in fused state. Fused state means it doesn't contain water, it contains solution itself. Solution forms by itself. That means, say for example, what is the difference between aqueous sodium chloride and fused sodium chloride? We can prepare aqueous sodium chloride by adding water. Okay, but when we talk about this fused sodium chloride, when we put the sodium chloride in a place, it contains, then it liquefy, so that it contains salt in a solution state. That is called fused sodium chloride. Then solutions of acid, aqueous hydrochloric and aqueous sulfuric acid. In addition to that, solution of bases like aqueous sodium hydroxide. Since we know the things about the electrolytes, we need to know about the non-electrolytes also. Non-electrolytes are the materials, are the liquids or solution which does not conduct electricity. Usually it is pure water. Pure water means the word that is distilled water. It is not, we are using just water. It is slightly acidic, but pure water. In distilled water, in laboratory scale, we are preparing distilled water. In laboratory purposes, those are non-electrolytes. And organic liquids like petrol, kerosene, paraffin, hexane. Those are non-electrolytes. When we talk about conductive materials, we need to talk about insulators also. What are insulators? Insulators means the materials which cannot carry electricity. That means wood, paper, those kind of examples can be given. Okay, those are just theory. Those who couldn't understand up to now, please let me know. Okay, this is about electrochemical cell. Please remember electrochemical cells and galvanic cells both are same. Cells, galvanic cell both are same. But electrolytic cells are different, okay? So, in day-to-day life, we have several experience related to the batteries. Batteries means series of electrochemical cells. Okay, so even the vehicles are powered by batteries. In addition to that, our mobile phones, computers, even laptops, even computer calculators, electric torch, any kind of toy cars, which is in some toy cars are powered by electrochemical cells. So we need to have rough idea related to the electrochemical cell. Can you see this? I took this image from your one of the O-level books. Okay, this is the simple electrochemical cell. That means this has a dilute sulfuric acid as a electrolyte and zinc metal strip as a electrodes. So when in electrochemical cells, it converts chemical energy into electrical energy. The reactions, it generates the energy via chemical reactions. Okay, here, when we put zinc metal strip into the dilute sulfuric acid, what will happen? Gas bubbles are liberated near the zinc strip and zinc strip is dissolved. That is the observation. Okay, then we can discuss how this happens. Okay, here what happens is there is a zinc metal strip. Now zinc metal strip contain zinc atoms. So zinc atoms leave in electrons and form zinc 2+ ions like this. Okay, that means electrons get accumulated on the zinc strip. Zinc එක ගාව electrons එකතු වෙනවා. මොකද zinc 2+ එන. ඒතර zinc 2+ එනවා කියන්නේ zinc දිය වෙලා යනවා. Then there is a sulfuric acid in the medium and it contains H plus ions. So sulfuric acid can be dissociated, ionized into as 2H plus SO4 2 minus. Then since zinc strip near the zinc strip, there are electrons. So from this H2SO4 molecule, it is ionized as H plus and SO4 2 minus. H plus is positively charged, and so it goes to the near to the zinc strip and it capture the electrons and form hydrogen gas. Okay, a hydrogen gas. Then hydrogen gas is formed near the zinc metal strip. So what happens? When what happens? Gas bubbles are liberated near the zinc strip. Okay, that is why, because H plus comes to the zinc strip and it took electrons from zinc. Then what happens? Then it become H2 and H2 gas is liberated. Okay, I will explain it again. Okay, this is the mama සිංහලෙන් එකපාරක් කියන්න. දැන් මෙහෙම මේක තමයි ඔයාලා දකින්න සිම්පල්ම සෙල් එක. හරිද? මොකද්ද කරලා තියෙන්නේ? බීකර් එකක් අරගෙන බීකරේට ඩයිලූට් සල්ෆියුරික් දාලා ඒකට මෙටල් ස්ට්‍රිප් එකක් දාලා තියෙනවා. මේක මෙහෙම වෙනකොට ඔයාලා මේකේ ඔබ්සර්වේෂන් එක ඔයාලා දකින්න මෙහෙම දැම්මහම ගෑස් බබල්ස් යනවා සිංක් ස්ට්‍රිප් එක ගන්න. මෙන්න මේ හරි. gas bubbles. Okay, gas bubbles are liberated. Okay, gas bubbles. Okay, then and the other thing is zinc strip is dissolves. ඒක දිය වෙනවා. මේකට වෙන්න පුළුවන් දේවල් තමයි මෙහෙම ඉලෙක්ට්‍රෝකෙමිකල් සෙල් එකක් තියෙනකොට මුලින්ම සිංක් ඉන්නවනේ. We will talk about the electrochemical series later on. අපි electrochemical series එක ගැන පස්සේ කතා කරමු. හරිද? මේකෙදි මොකද වෙන්නේ? මේක තියෙන zinc ionized වෙනවා zinc 2 plus විදිහට. ඒතර zinc 2 plus වෙද්දී electrochemical cells ලියනකොට මේ අපි සාමාන්‍යයෙන් balance වෙන්න ඕනේ left hand side එකයි right hand side එකයි. එතකොට මේකේ left hand side එකේ තියෙන zinc solid කියන එක විතරයි ඒ පැත්ත neutral. ඒතර zinc solid zinc 2 plus වෙනවා කියන්නේ ඒ කියන්නේ electrons දෙකක් අයින් වෙනවා. එතකොට ඒකට electrons දෙකක් අපි දානවා. තේරුණාද නැත්නම් මේක හරියට වෙන්නේ මේ විදිහට zinc එකෙන් zinc again 2 electrons remove වෙලා okay it forms zinc 2 plus. But guys, when you write the equations, okay, when we write the equations, we cannot put the minus. It is just a so that's why we are taking this one to this side. Then it become plus 2e. Did you get it? Then ඊට පස්සේ මෙතන ඉලෙක්ට්‍රෝන තියෙනවා දැන් සිංක් ස්ට්‍රිප් එක ගාව. එතකොට H2SO4 තියෙනවා සොලියුෂන් එකේ. සොලියුෂන් එකේ H2SO4 තිබුණාම මොකද වෙන්නේ? ඒක කොහොමද අයනයිස් වෙලා තියෙන්නේ H+ and SO4 2- වලට. එතකොට මොකද වෙන්නේ මේ H+ ගිහිල්ලා යනවා zinc 2+ තියෙන තැනට ඉලෙක්ට්‍රෝන්ස් තියෙන තැනට. එයා ඉලෙක්ට්‍රෝන්ස් එකතු කරගෙන H2 බවට පත් වෙනවා. එතකොට එයා ඉන්න zinc strip එක ගාවින් එතකොට zinc strip එක ගාවින් H2 release වෙනවා. එතකොට total equation එක. එතකොට හරිනම් equations ලියනකොට electrons දෙපැත්තට එක electron එක equation එක electrons දකුණු පැත්තට එවන අනිත් පැත්තේ වම් පැත්තට එන්න ඕනේ. එහෙම වුණොත් තමයි ඉලෙක්ට්‍රොන්ස් ගන්න. එතකොට අපිට පුළුවන් මේ දෙක එකතු කරලා හරි කොහොම හරි කරලා බැලන්ස්ඩ් half reaction එක ගන්න නැත්නම් balanced ionic equation එක ගන්න පුළුවන්. By adding both. Did you get it? Kavinda.
Yes.
Okay, then I will explain why then you may have a problem. Why zinc oxidized? Why can't H+ cannot be oxidized? H+ cannot be oxidized, or why sulfate cannot be oxidized? That kind of questions can be come to your mind. So I will explain it using this one. This is known as electrochemical series. Okay, in my there is the electrochemical series. We believe that the electrons from the elements from upper side, are tend to oxidize. That means if their reduction potential is negative, they tend to oxidize. Okay, the electrons below the hydrogen act as a standard potential, standard one, so we take it as 0. Below the hydrogen, they are having positive values. They tend to have reduce. So before that, but anyway, that means when we produce a cell, okay, there can be two phenomena, like one is the oxidation, the other one is the reduction. So in electrochemical series, if both elements are in electrochemical series, the element which is in upper state, okay, it is undergoing oxidation. Then other one undergoing reduction. So say for example like this. Think about sodium and copper. Okay, where is the oxidation taken place? Where is the reduction is taken place? උඩ ඉන්න එක්කෙනා අනිවාර්යයෙන්ම ඔක්සිඩයිස් වෙනවා අනිත් එක්කෙනා රෙඩියුස් වෙනවා. මොකද්ද එතකොට උඩ ඉන්නේ? Talk with me. Please think about two metals. Please tell me which is oxidized and which is reduced. First side, oxidation. This side, reduction. Okay. So sodium will oxidize, copper will reduce. Did you get it? When we write the half reactions to write the standard reduction potential, we write like this as the order of reduction. ඔයාලට තේරුණාද මම කියපු එක? තේරෙන්නේ නැත්නම් අහන්න. Okay, think about these two. Iron and iron and silver. What will be oxidized? What will be reduced? Please tell me. Think about making a electrochemical cell using these two metals, iron and silver. අයනුයි සිල්වයි එකතු කරලා සෙල් එකක් හදනවා කියලා හිතන්න. ඒකේ ඔක්සිඩේෂන් එක වෙන්නේ මොකේද එතකොට? උඩින් එන එක. Okay. Okay. Shamitra, you are right. Then I will explain it again. Okay. When there is a electrochemical cell, okay, there is a place where oxidation is taken place and the other place reduction is taken place. I think if you don't understand that, there are two ends like two ends maybe anode and cathode. දෙකක් තියෙනවා anode එකයි cathode එකයි කියලා. Okay, Tarushi also right. Okay, then එතකොට මේක මෙහෙම වෙනකොට ඔක්සිඩේෂන් එකයි රිඩක්ෂන් එකයි වෙනකොට සාමාන්‍යයෙන් ඒක අපි බලන්නේ කවුද ඔක්සිඩයිස් වෙන්නේ කවුද රෙඩියුස් වෙන්නේ කියලා මෙන්න මේ සීරීස් එකේ. මෙයාට අපි කියන ඉලෙක්ට්‍රෝකෙමිකල් සීරීස් කියලා. මේක ලියලා තියෙන විදිය ගැන හිතන්න එපා, මෙටල් එක ගැන විතරක් හිතන්න. ඔය ස්ටෑන්ඩඩ් රිඩක්ෂන් පොටෙන්ෂියල් ලියන හින්දා මෙයාලා රෙඩියුස් වෙන පැත්තට තමයි හැම එකම ලියලා තියෙන්නේ. එතකොට ඒ ගැන හිතන්න එපා, මෙටල් එක ගැන විතරක් හිතන්න. එතකොට අපි මොකක් හරි දෙකක් සිලෙක්ට් කරනකොට ඒකේ උඩින් ඉන්න කෙනා ඉලෙක්ට්‍රෝකෙමිකල් සීරීස් එකෙන් තමයි යාලා බලලා සිලෙක්ට් කරන්නේ. ඒකේ උඩින් ඉන්න කෙනා ඔක්සිඩේෂන් එක වෙනවා. අනිත් එක්කෙනා රිඩක්ෂන් එක වෙනවා. තේරුණාද? එතකොට ඔක්සිඩේෂන් වෙන්නේ ඇනෝඩ් එකේ ඉලෙක්ට්‍රෝකෙමිකල් සෙල් එක. රිඩක්ෂන් එක වෙන්නේ කතෝඩ් එකේ. Did you get it, guys? Those who couldn't understand even now, please let me know. I am repeating this again. In when we make the electrochemical cells, we need to consider about anode and cathode, or else the place where oxidation is taken place and the place where reduction is taken place. Okay, so guys, when we prepare electrochemical cells, so electrochemical series must be considered. So the elements which is in upper state or in electrochemical cells are used for anodes. The electrochemical elements which is compared to that prior one in a lower state, it is known as reduction or it is taken as cathode. Okay, did you get it, guys? So now your question is solved, I think, because then earlier you had that doubt. No, here this contain zinc and dilute sulfuric acid, but dilute sulfuric acid is also ionized to H plus and SO4. So zinc, we have a zinc. Here zinc. Okay, then H plus, no, H plus here. Okay, so the elements which is in upper state undergo the oxidation. This is reduction. Did you guys got it? Okay, but the thing is, you need to know now You have rough idea how to get that one. Okay, then we can write those 1 and 2 are known as half reactions. Okay, because the equations which contain electrons, we know it as half reactions. I'll put it here. Okay. Yes. You need to memorize the table because we don't give the electrochemical series anyway. You need to. I will give you these. There are a few examples, and if you can memorize it would be better. Okay, equation 1 and 2 are known as half reactions. Then adding two half reactions. When we add the half reactions, did you remember the simultaneous equations? සමගාමී සමීකරණ එතකොට අපි ඒ කියන්නේ X hari Y hari සමාන කරලානේ ගන්න ඒ වගේ තමයි මෙතනත්. We need to there are electrons in both sides, but when we add it, electrons can be cut in both sides. Finally, we can get the ionic equation. So, in this case, think about this. If zinc has 1 electron, if H has 2 electron, what can we do? We need to multiply zinc first by 2 times. Then only we can get 2 electrons in both sides. Okay, we'll see when there are that kind of examples. Examples also. So this is how balanced ionic equation is written. Okay, then this is balanced one. No? Then if we want to write the equation, balanced chemical equation, this is known as balanced chemical equation. You need to write without electrons, without ions. Okay, did you get it? How? Because H plus and SO4 is given by H2SO. So we can write it as H2SO4. Then zinc and SO4 minus is combined together. Both the ions form zinc sulfate ionic compound. This is known as balanced chemical equation. Okay, then we'll move on to the second one. Okay, here only one type of zinc metal strip. Normally, when we make a electrochemical cell, there must be 2 ends. Okay, here there is 2 electrodes. I think you know the term of electrodes. Zinc strip and copper strip, and there is an ammeter is also connected to the circuit, and again dilute sulfuric acid is added as the solution or else electrolyte. Okay, the observation is ammeter point is deflected. Okay, that means ammeter pointer is deflected, zinc strip is dissolved, and gas bubbles are evolved at the copper strip. Okay, can you please get the idea? Where the oxidation is taken place in this zinc and copper. Okay, really sorry. Can someone please tell me where the oxidation is taken place? Which electrode will oxidize? Hmm? Now think about this one. Okay, one gave correct answer. What about the others? Chamikara, you are right. Okay, it is happened in zinc plate. Okay, so that is why zinc strip is dissolved. What is the reason why ammeter pointer is deflected? Ammeter එක reading එකක් පෙන්නන්නේ ඇයි? The current is flow through the circuit. That is why current is flow through the circuit. That is why it shows deflection. And then think about zinc strip release electrons. Then if it is oxidized, it will become 2 plus, zinc 2 plus. Then what happens? It releases 2 electrons. Did you remember last case? And then these electrons goes through there like this way. Okay, this way electrons. The place where oxidation is taken place as known as anode. Okay, this is anode. Okay, I will give the note later, I think. This is cathode. Okay, then electrons are transferred in this way. Okay. Then electrons are accumulated at the copper. Here electrons are there. Then these electrons are taken from the H plus. Okay. As a result of that, gas bubbles are evolved from here. Did you get what happened? When you see the observations, you can get idea. I gave all the notes here. You can read it anytime, anywhere, okay? Please put the message those who couldn't understand what has happened in here. Okay, this is what happens here. Here, negative terminal is anode in electrochemical cells, okay? But when it's come to the electrolytic cells, it is different. Okay, did you get it, guys? Those who couldn't understand, please put a message. Teru natiyaya mad message kadda. Okay, at the zinc electrode, oxidation is taken place and zinc becomes zinc 2 plus and release 2 electrons. At the copper electrode, at the positive terminals, H plus accumulates that electrons and produce H2. So overall cell reaction, so balanced ionic equation is zinc, we can take it by adding 1 and 2 equations. The zinc solid plus the 2H plus aqueous. We can obtain zinc 2 plus and H2 gas is liberated. Okay, here. This one, loss of electrons from the given species is known as oxidation. So what is happening at the zinc strip is oxidation. So oxidation occurs at the certain electron is defined as anode. Okay, gain in electrons by given species is known as reduction. The reduction occurs at the electrode is known as cathode. No, it won't be given. Anodic and cathodic equations will not be given. You need to write it, okay? Only this cell is given. මේ cell එක විතරයි දෙන්නේ. එක මොකද්ද? cathodic reaction එක මොකද්ද කියලා. ඒ ටික තමයි අහන්නේ විභාගෙදී ඈ. Only this cell is given. The questions can be asked: what is the cathode? What is the anode? What is the cathodic reaction? What is the anodic reaction? What is the observations? Okay, those are the questions can be asked. That is why you need to remember the electrochemical series. When we we need to identify the cathode and anode, no? So there are some facts you can use. I already told you the metal placed higher in the activity series. That means this one. This is the activity series, electrochemical series. Higher act as the anode and the place lower act as the cathode. And the other one is the oxidation occurs at the anode and reduction occurs at the cathode. And anode become negative terminal, whereas cathode become positive terminal. Those are the things you need to remember. Then we'll go to the next one. Can you please tell me what is the anode and what is the cathode? I will show you the electrochemical series. This one electrochemical series. This is I already written here. Copper and iron. What will be the anode? Copper or iron? Copper is here. And the other one is iron is here. Okay. So anode will be copper. It is in higher state of in the active series. And iron will be the cathode. I think now you know how to get it. Okay, then what will be the observation? Cathode will dissolve and then again we will go to the active series. Yeah, iron and copper. Okay, we need to consider this iron, okay? Because this one iron and this one copper. So then iron act as anode, no? Because or else if we take this iron, this is not stable in this is not form in metal, no? This is not stable in air, normal state. That is why we can't take this iron. We cannot take this. So we can take Fe2 plus 2 Fe. Okay. Then iron become anode and iron release electrons. It's go to the copper and near the copper strip, H2 gas will be evolved. That will be the observations. Okay, so Fe become Fe2 plus 2E. Then the electron is gained from copper, and at the copper electrons to H plus is that electron is taken by H plus and form H2. Okay, this is the balanced ionic equation. Then this one. Zinc and iron, definitely zinc is in higher state. Okay, then zinc. And then zinc will be the anode and iron will be the cathode. So zinc is oxidized, definitely. Then electron is goes to the iron, and near the iron, H2 is released. That is what it is happened with there. Can you get it? Now, do you have any idea what is happened in here? Those who couldn't, only you need to identify cathode and anode. Then it is very easy. In many cases, in anode side, the cathode side, H2 is liberated. If you have any doubts, please let me know. Then we'll go to the last part of our lesson. Okay, then I'll move on to the next session. Okay, before for this we are measuring the electrode potential between the two electrodes. That is what electrode potential means. Voltage between two electrodes, that is the electrode potential in an electrochemical cell. So it is affected by temperature concentration of the electrolyte, nature of the electrolyte, pressure of the gas, and type of the electrolyte. Then we will move on to the electrolysis. Okay, electrolysis is the process, it is non-spontaneous process. මේක නිකං ඇති වෙන process එකක් නෙමෙයි. We need to give electricity from external source. So think about that. This is electrochemical cell. Do we need to give any electricity? Do we need to supply any electricity here? No, it is generated its electricity by chemical reactions. But when it's come to the electrolytic cells, okay, we need to give electricity by external electric sources. Okay, then only reaction is happened. Okay, can you see the difference between the electrochemical cells and electrolytic cells? Electrochemical cells, it produces electricity by itself, but here we need to give external source of electricity to generate the electricity in electrolytic cells. Did you get it, guys, the difference? Okay, so dissociation of compound by passing electric current through it. We will pass electric current through it. It is known as electrolysis. Please be aware of the differences, okay? And the other thing is in electrochemical cells, we told about the anode and cathode is negative terminal, cathode is positive terminal. Here in electrolytic cells, the opposite is happen. Anode is positive terminal, cathode is negative terminal. But oxidation is taken place in anode, reduction is taken place in cathode. When conducting electrolysis, the electrode connect to the positive terminal is positive electrode. Okay, electrode connect to the negative terminal, it is negative electrode cathode. Did you get the difference? So, but anode is undergoing oxidation, reduction is happened at cathode. Then we will think about the first example as electrolysis of water. Usually, the pure water cannot be electrolyzed. It is non-electrolyte. Here, water contain, normal water contain carbon dioxide. So it is little acidic. But if that acidity is not enough, we can add dilute H2SO4 into the water. Okay, here we are using platinum wires for this setup, and hydrogen and oxygens are liberated at the end. So at the anode, oxygen is liberated. At the cathode, H2 is liberated. Can you see the amount? The amount of hydrogen released is as twice as it is oxygen amount of oxygen released at the anode is half of that amount of hydrogen released. So think about the overall reaction. Okay, when we think about the overall reactions, even though we added H2SO4, H2SO4 doesn't have any enough in that reactions. Then this one, electrolysis of copper sulfate using copper electrodes. Okay, here we are giving electricity by using 9-volt electrode. Okay, this phenomenon can be used for the electroplating process also. Here, impure copper rod. That means impurity 3 copper use करना anode के विधि pure copper is used as cathode. Then what happens when electricity is provided? Oxidation is happened at the copper anode, so copper become copper 2 plus. So pure copper metals goes to the cathode, and then cathode accumulate electrons, and copper is deposited on the cathode. So in that cases, we are using copper sulfate solution is electrolyte medium. Did you get it? Anode is dissolving, and at the cathode, copper is deposited. Okay, electrolysis of copper sulfate using inlet electrodes. This is same as the earlier figure, this figure. Okay, so here, since they don't have any copper electrodes, what happens at the anode? Oxygen is released. At the cathode, since the solution is copper sulfate, copper is deposited at the cathode. Okay, that is what happened. Then this is bit important. So quantitative aspects of electrolysis, there are two rules. I think you know this one. Faraday's laws of electrolysis. Okay, the first law is the amount of chemical reaction which occurs at an electrode during electrolysis by a current is proportional to the quantity of electricity passed through the electrolyte. That means the electricity passed through the electrolysis that means amount of chemical reaction occurred at the electrodes is proportional to the quantity of electricity passed through the electrolytes. Okay, that is one. The other one is the amount of different substances liberated by the same quantity of electricity passing through the electrolytic solutions are proportional to their chemical equivalent weights, atomic mass or something. Okay, so you need to memorize these two laws. Then we'll go to the applications. Before moving to the applications, the quantity of the electricity is Q. We can write the equation as Q is equal to IT. Okay, the unit of the Q is ampere seconds. So think about this one. The amount of electricity required for the oxidation or reduction depends on the stereochemistry of the electrode reaction. Think about the reduction of silver. Here Ag plus release its oxygen, take one of the oxygen and produce silver. 1 mole of electrons is required to reduce 1 mole of zinc ions. Can you see this? 1 mole of electron is needed for this reaction. So 1 electron charge is equal to 1.6021 into 10 to the power minus 19. So that means we can get we can multiply, okay, by multiply it by charge. charge and with the Avogadro constant, we can get the charge on one molecule. Charge of one electron multiplied by the Avogadro number, we can get the charge of 1 mole. Charge of 1 mole is equal to this value, 96,487. It is known as Faraday constant. If one electron is released in the system, the charge is 96,487. If 2 electrons are released, it is equal to the 2F. If 3 electrons are released, it is equal to the 3F. You need to memorize all the things. Okay, please calculate this one using this equation. Q is equal to IT. We need the charge. Okay, I is given. I mean current. H is also given. Hour. So here it is mentioned as you need to take the values from seconds. Using this equation, please find the charge passed when dilute H2S of a solution is electrolyzed. One gave the answer. I is 1.5 ampere multiplied by hours. Now we need to convert it to seconds. 5 into 60, then it converted to minutes, then seconds. What is the answer? Okay, Sajivan, you answer right. Iman, your answer is also right. It's 7,000 ampere seconds. Okay, or else you can put it as coulombs. Okay. S must be simple. Okay, I think you all got the idea. So this is the last slide. Okay, comparison of galvanic cells means electrochemical cells and electrolytic cells. What we have called, this is a spontaneous process. That means chemical energy is converted to electrical energy in galvanic or electrochemical cells. Galvanic also same as electrochemical cells. Okay, then electrolytic cells, it is not spontaneous. We need to give external electric supply by battery. The anode in galvanic cell is negatively charged and oxidation is happened. Here electrolytic cell anode is positively charged and oxidation is taken place. Cathode is positively charged in galvanic cells and reduction is happened there. Cathode also in electrolytic cells, cathode is negatively charged and reduction is taken place. Okay, with this, I'll wind up the today's session. But anyway, you need to do there are things to refer. Wait, I'll give you the topics to refer. You need to refer what? Okay, I'll send you your second assignment. It will be the group assignment. I will send the Kavishka, I couldn't understand what you told. Temperature, no? Yes. ආයෙත් මට ඒක මැසේජ් එක දාන්න පුතා මට ඒක තේරෙන්නේ. The other one is standards to measure environmental control. Measure the pollution. You need to refer, okay? I will give you one question from this one. Okay, if you have any doubts, please let me know, or else I'll wind up this session and I'll inform you whether we will conduct the quiz, which will be composed of, I think, mostly 10 MCQs plus 2 or 3 uh, structured essay questions. Okay, I'll inform the date. When you come physically, I'll conduct one quiz. Then it will be over. Then I'll give you the assignment 2, and you need to submit the presentation. Then we will present. 1 or 2 from your group need to present. Okay. So if you have any doubts, please let me know, or else I'll wind up the session. I'll send you these slides now. Okay, since you don't have any. Okay. No. It doesn't make any sense with the temperature. एक temperature का तक मेरा swing नहीं. Okay. So I'll wind up the session. Thank you very much. Only half of you have participated in today's lectures. Okay. Have a nice day to you all.